Hey everybody, this is Larry. This is day 4 of the August Leetcode Daily Challenge. Let's get started. Power 4. Hit the like button, hit the subscribe button, and join me on Discord. Given an integer, write a function to check whether it's a power 4. Okay. So you could do it with a loop pretty trivially. Can you solve it without loops and recursions? Yeah. So how do you? So let's start with something even easier, right? How can you tell if something is power of 2? So something is power of 2 is if it's 1, and then in binary is if it has 1 and then there's a lot of zeros in afterwards, right? And then I imagine that for powers of 4 is the same thing, which is that there's 1 with a lot of zeros, but it has to be pairs of zeros, for each of them being a 4, multiple of 4, right? So how do we check this? In one, how do we check this usually, right? Because in this case, this is not, because there are odd number of zeros. So I think this is more of a brain teaser. I mean, if you get this in a competitive program problem or even interview, I would probably just suggest a for loop and ask if your interviewer is okay, or if it's not, I'm sure they'll let you know. But okay, so then the traditional one is that num n num minus 1 is equal to 0. So that's to check if it's a power of 2. And then now, let me think about how do I get it? How do I convert this to 4, right? To power 4. Let's see. So let's say we have number 16. So 16 is just this, I think, 2 to the 5th. So then, what's 13 in binary? So can we do something like that where we know that it's going to be a power of 2, right? Because if it's not a power of 2, then it cannot be a power of 4. Then can we divide it by 2? Is it still a power of 2 now? Because even 2 to the third is 8, and that still would be true. So we want the square root of nums, and then see if the square root of num is power of 2. Okay. I think I could take that. So I could just return this. So this is if a number is power of 2, but also handles just like making sure it's an integer and all that stuff. And then maybe something like n. So square root is equal to let's just say int. Yeah. Maybe something like that. So 4, 16, and then with a 64 afterwards, and then 28 to 56. Let's play around with a few and then see if that works. That looks okay, so let's submit it. Ooh. Oh, okay, I forgot about the negative case. Whoops. If num oh, and 0 case. Okay, well, maybe I'm just very careless today. Just woke up. That's my excuse. I'm sticking to it. Wow, really should probably put in some of these. I'm just being a little bit lazy, but is that the only case? That's No, I guess 2 will be the only case. I mean, I could have made that special. It's that so the reason why this is the case is because for 2, this returns 1, and 1 is a power of 2, but a power of but but that's because this is rounding off, and this is the only time where this is the case. I guess to be more precise, I thought about this while I was doing it, but I guess I was a little bit lazy in the proof. But basically, what we want is if basically we just want to make sure that it's a perfect square. Perfect square root for it to be a power of 4. There we go. Let's submit again, and hopefully we have the 3 wrong answers. Okay, there we go. So of course there are many ways to do it. I chose to try to do it in a way that is a little bit cuter than I would normally do it. And again, in a contest or in an interview, I would start the for loop or something like that and then work my way through this solution. I definitely also should have checked the constraints a little bit better. I just for some reason expected to be positive number, which I would still have gotten 1 wrong, but at least 1 wrong anyway. But yeah, overall, I think conceptually is pretty okay. Let me know what you think, and I will see y'all tomorrow. Bye bye.